Recording. Good morning, everybody. My name's Jo from STEMPOINT, and I'd like to welcome you to Space for You, which is a panel talk. We've got a panel of experts who are going to be introducing themselves. And just very briefly, a little bit about the Space Inspirations slide. Space Inspirations. These are our panelists. You're going to be hearing from all of them. So we've got a wide range of skills and expertise there. And then Space Inspirations, it's a programme that is sponsored by the European Space Agency to address
You've muted yourself, Jo.
Thank you. Sorry about that. So welcome, everybody. We've got our expert panel. With us today. You're going to be hearing from them and a little bit there about the Space Inspirations programme to inspire the next generation of space experts. Vital in the UK space sector so that the space sector can fulfil its potential. So different workshops like this today, our panel talk, to help raise awareness of careers and skills needed in the space industry. Without further ado, I'm going to pass over to Stuart Catchpole, and I'm just going to say a thank you now to all of our panelists for coming together for this workshop today. Thank you.
Thank you, Jo. Hello, everyone. Thank you for joining us. We've got a very exciting panel event for you this morning. My name's Stuart Catchpole. I'm the Space Cluster Development Manager for Space East. What does that mean? It means we're one of 15 organisations that are working around the country to support the space sector and support businesses in the space sector, to support businesses who might be interested in the space sector and to benefit from it, to be able to grow and advance collectively. So as a cluster, we represent the East of England, and we have a range of different organisations who are part of our cluster. And this just gives you a bit of a flavour as to some of those sorts of businesses. So Teledyne E2V make the optical imaging technology that you'll see from the images from the James Webb and the Hubble telescope. So those fantastic images of the universe and the cosmos. Equip make electric vehicles, but also produce electric motors for Gilmour and the Australian Space Programme. BT are interested in telecommunications, obviously using satellite technology. We have companies who operate drones using GPS technology like HexCam. We've got companies who use optical imaging for infrared purposes that can be applied to agriculture like SuperSharp. And we've got companies like AST Technologies who are interested in the marine environments and making sure that boats out in the middle of nowhere have telecoms capability and people can continue to communicate with each other, and you can also track where your assets are. So it's a really wide and varied range of businesses that we have in the East of England, and particularly across the whole of the United Kingdom. So as I said, we've got 170 of those business members, and our job really is to support them with all of their needs. One of those particularly is around the skills environment, and we're always looking for the next talent coming through. So this is a really interesting and useful opportunity for us all this morning to talk to you about what career opportunities there are in the space sector, and hopefully steer you towards thinking about what you might like to do in the future. So I'm very pleased to be joined by a fantastic panel this morning. I'm going to let them introduce themselves, but starting with Kathy.
Hi, thanks so much, Stuart. My name's Kathy Bowden, and I'm calling you or speaking to you from the Satellite Applications Catapult, and we're situated in one of those clusters that Stuart just showed on the map. I'm based in Harwell near Oxford, but I work with a lot of the different clusters around the country. And I think one of the things that's worth introducing me with is the fact that when I went through school, I really didn't know there was a space sector. You know, we talked today about not knowing that the UK is involved with space. Well, believe me, back in those days, there was even less knowledge than there is today. And I wanted a job that ultimately was going to enable me to travel, hopefully for somebody at somebody else's expense, and to work outdoors. So I went and did geology at university and went and joined a mining company. And within months of me joining them, they said, well, there's this new technology that we want to know more about, and it uses satellites. And kind of the rest is history. I was able to do that traveling at their expense. I was able to work out of doors, and I was able to apply my knowledge of Earth observation in all sorts of different worlds. So I've been able to work outside, exploring for gold and diamonds and interesting products like that. But then also to come into a more satisfying world now, because I don't necessarily want to be outside in the rain all the time, but to be involved with so many exciting things to do with space. So there's so much opportunity for us to have fun that no day is ever the same for me. So let me hand over to the next person.
Thank you, Kathy. Nuala.
Yeah, hi everyone. So my name is Nuala, and I'm really feel honored to be here today. So my journey into the fascinating world of space began when I was in year 10, where I learned about the life cycle of a star, which is what you can see up on the screen right now. And this includes how black holes are made. And I thought this was like one of the coolest things I'd ever learned. And I really wanted to find out as much about it as possible. And it really sparked my interest in space. So I chose to study physics and maths and biology at A level. And then I went on to study physics and astrophysics at university, where I got to learn so many amazing things about space and the universe and all of the incredible maths that we use to understand it. And I also got to use a telescope for the first time and got to take really incredible pictures of space. Can I go to the next slide? I actually don't know. Or is that you, Stuart? Thank you, Stuart. So this is a picture of space. It's the Soap Bubble Nebula. So this was something I got to do at university, use a telescope, take images of space. And it was actually surprisingly difficult, but it was also really incredible as well. And taking pictures of space isn't just for taking pretty pictures of space and astronomy. It's how we study the universe and learn more things about it. And while I was at university, I also realized that I really love talking to people about space and getting people just as excited about it as I am. So when I graduated university, I was looking for jobs in a field called science communication, which is basically just a job where you get to talk to people about space and science all day, which is great for me because I love doing that. And that is now what I do at the University of Hertfordshire. So my official title is an Outreach and Public Engagement Manager, and I work in the Department of Physics, Astronomy and Maths. I get to teach the local community about all of the amazing science and maths in space, and I mainly run workshops for local primary and secondary schools that spark excitement and curiosity about the world of space, science and maths. And one of the highlights of my role is running events at the University of Hertfordshire Bayford-Bree Observatory, which is what you can see behind me here and also up on the screen now. So all of these like dome things, and in the picture with all the grass and all of those domes, inside of there is a telescope. And that's what we use to take photos of space and study it. So when we run events at the observatory, so we're open to the public, lots of time we have like school trips and also really big open evenings as well. I get to guide visitors in using telescopes like we can see this man doing here, and letting them see planets like Jupiter up close for the first time, which is such a privilege and a real experience for people to share together, which is really lovely. And in my job as well, I also have a picture up there of the aurora that we took over Bayford Observatory. So I don't know if anyone got to see the aurora about a month ago. It came like really far down south. I was actually in London at the time, and you could even see it out my bedroom window. But some of my colleagues got this amazing picture of the aurora over the observatory with all these beautiful red colours. And yeah, so in my job as well, I often have to speak to young people about careers in the space industry as well. And in doing so, I've actually learned a lot about all of the amazing careers that there are in the space industry and how it goes beyond sort of my limited knowledge. At first, I thought it was just about like studying space and understand it, but it's also about all of the technology that's needed and the applications that these have, not just for advancing our understanding of the universe, but really helping us here on Earth, especially using like satellite technology, which a lot of the people here today use. And then just when I'm not immersed in the world of space because I do have a life outside of science. I try to get outside as much as possible. I really love nature, and I also love doing sport like running or football, and I really enjoy painting as well, although I'm not very good about it, but I'm trying to get better every day. So yeah, that's a little bit about me and my sort of journey into the space industry. Thank you.
Thank you, Nuala. Super interesting. We'll hear more about that later. Jake, over to you.
Hi everyone, good morning. My name is Jake Gear. I'm calling you today from the south coast, a place called Winchester. I have been in the space sector for around about 7 years now. I run a company called Orbit Fab. So we're a satellite refueling company. If you think of cars can be refueled, trucks, planes, boats, whatever, they can all be refueled with petrol or diesel or whatever they knew, electric cars as well. In space, you can't refuel anything unless you've got an astronaut there to actually do the refueling on the space station or from a space shuttle or something very exciting, which doesn't happen very often. Then you have to throw your satellite or your spacecraft away when it runs out of fuel. And my company's trying to change that. We're trying to make it so that space is more sustainable. You don't have to throw away satellites when they run out of fuel. You can instead use one of our little satellites, a fuel shuttle or a fuel tanker that goes up into space on a rocket and then can dock with your spacecraft and refuel it so it can carry on doing what it needs to do. And satellites do so many things. But when you look at your phone and you look at your Google Maps or whatever mapping app you use, or you take a phone call from far away, or maybe you use internet banking or anything like that, chances are there's a satellite somewhere in the chain of clever stuff that makes that happen to enable it to happen worldwide. Because a lot of data comes up to satellites and goes back down as well as the cameras on satellites helping us understand the Earth too. So it's really important to be able to use satellites more now and use them a bit better and more sustainably, particularly as we have a problem of something called space debris. So that's all about the things that we leave in space, like pollution that we've left in space from the stuff we've done over the last 40 or 50 years. Every time a rocket goes up there, it leaves a little bit of the rocket that stays in space, and gravity doesn't bring it back down for tens or even hundreds of years. And the further you go out into orbit, there's lots of different levels of orbit. The further out you go, the longer that stuff stays in space. And it can crash into other satellites, or even in some cases, make some parts of space inaccessible for all of us in the future. So it's really important to me, and I hope to you as well, of people that will be using and hopefully going to space one day as well, to make space more sustainable. Now, a little bit about me and my journey into the sector. I've got lots of pictures and stuff here about the sort of jobs that I've done by different ages. I want to start just a bit before the age of 13 and let you into a secret, which is that I was not very good at science at school. I was okay at maths, I was okay at English. I was not very good at science at all. I worked hard at it, I kept going. I didn't really understand what I could do in the space sector. I thought it was just all about astronauts and you had to be like military test pilots and really good at science. So I didn't think it was me. But as I went through my career and I did what I was good at, I was good at English, I was good at some forms of maths as well. You can see I did just whatever job I needed to do when I was under 21. I was a waiter, I was a labourer, I worked in a prison tuck shop for a few years, which was a particularly exciting but unusual job. And then I went to university and I studied psychology. So not very sciencey, not very spacey so far, right? Then I just wanted to do something that I found interesting. So I joined the Ministry of Defence after a short career in market research. I deployed to places like Afghanistan and helped operations in places like Iraq, Libya, Syria, and Sierra Leone. By using my math skills, statistics, analysis, lots of graphs, lots of Microsoft Excel, Microsoft Access. Some of your teachers might remember that. Not many other people do. Using all those maths and statistics skills to understand more about the world and tell people about that as well. And then I switched career, age about 32. I realised that space wasn't just for people that were really deep into science that had PhDs. There's lots of people on this call, on this panel, who have got PhDs, and I'm amazed by them because that takes so much work. I was never that good at science, so it was never the route for me in particular. But I realised that by doing what I was good at, bits of maths, bits of psychology, helping people work together, being a good team player, understanding a bit about economics and how the country works as well, I could do something there to help the space sector. I've always been fascinated by space as well. So when I was age 32, I joined the UK Space Agency. So the UK does have a space agency, a bit like NASA, just a tiny bit smaller. We're based across the UK. We've got presences in various different clusters, as well as around London, Harwell, Leicester, and other places like that. I joined there to set up their launch program to try and launch rockets from Scotland, from Cornwall, and other places as well, Wales too, to try and launch rockets from there. Then I moved into space debris, so trying to track the debris in orbit with radars in places like Yorkshire or Sussex, and even in the far north tip of Scotland. And then I moved into different programs where I wanted to understand how I could stop this debris from happening, either to stop creating new debris to make it more sustainable, like by refueling spacecraft, or to take debris out of orbit, to get these big robots that find a piece of debris, come and capture it, and then drag it down and deorbit it in the Earth's atmosphere, where it burns up mostly harmlessly. So I studied that for years and years, and did my bit to try and push that forward for the UK and Europe as well, using those skills I got as a team player, using my way of working with people that I learned from my humanities and other such things as well. And then I became something called a chief of staff, which is like a leader. It's a bit like a deputy head or a deputy program leader or whatever you might have where you study. That's where I had to work with lots of different people to try and make them work better to achieve what they wanted to do. And I did that for a good couple of years and had a great time with the space agency. And I left and joined Orbit Fab, the space refueling company, around about 4 or 5 months ago. And I've had a great time working in both industry and government in the space sector. And my final message to you before I hand over is there's a space for everyone in space. If you do humanities or science or whatever you're good at, there's some job out there. I know some space lawyers out there who are very particularly cool at space stuff. There's something for everyone there for you as well. Stuart, back to you.
Brilliant. Thanks, Jake. Great message. We'll pick up some of those threads as we go into the panel session. Our last panelist is Emily. Over to you.
Yes. Hi, everyone. My name is Emily Hertig. I'm 25 years old. I come from Switzerland, and I'm a PhD student at the University of Cambridge. So this slide is kind of summarizing my journey so far. I started becoming interested in astronomy when I was quite young, about 12 years old. And similar to Nuala's story, I actually got interested in it after learning about some basics of astronomy at school and hearing about some aspects. For me, it was an activity actually in school where we made a scale model of the solar system, and I realized how small the Earth really is and how large distances in space are. And it fascinated me that there was so much more out there than what we can see on our Earth. And, just looking up at the stars at night became so much more meaningful, knowing how much there is still to discover. So this is how my passion started. Of course, the course that we had in school was quite short, quite basic. So I just kept reading about it, reading about astronomy on my own. And I got some amazing opportunities. You can see the first picture here on top. That's mini me, 12-year-old me, meeting Professor Didier Queloz, who is a very famous Swiss astronomer. He won the Nobel Prize in Physics in 2019. So he hadn't won the Nobel Prize yet when I met him. He was working in Geneva, near where I lived. And he gave me and my parents a tour of his office, of the observatory in Geneva, gave a small interview that was originally for a school project where I had to describe my future job. So I went up to interview him. He was so kind of him to give this time. He was already quite famous at the time. He was responsible for the discovery of the first exoplanet, so a planet that orbits another star than the sun. And it was amazing, really, to meet him, a true inspiration. So fast forward a few years, in high school, the equivalent of pretty much the years before A-levels in the UK, I started taking as many options as I could, as many courses in math and physics as I could, because I knew that I wanted to study astrophysics. And I had the chance to do a small research project, not exactly research because it wasn't fully original, but more like a review and write a small thesis, kind of like an article, make some simulations. That was my first experience with computer programming with solving equations of motions, and I was looking at the motion of small objects in the solar system. So if you have a two-body system like the Earth and the Moon, or the Sun and the Earth, any kind of two bodies that orbit around each other due to gravity, if you add a smaller object, there are some positions where it is kind of stable and it can have some special trajectories that I was looking into and simulating. So yeah, you can see here, for example, if you have the Earth here and the Sun here, you've got two of those points where we can actually send satellites or objects with trajectories that spend a lot less energy than they would otherwise, because they kind of go there naturally with gravity. So that was my first foray into research, and I absolutely loved it. So I took this project and I presented it at several competitions and events. This was a national science competition in Switzerland where I presented some posters and I was showing my interactive simulations here on the screen. And it was really, really amazing for 2 days to be talking about my work. And that's how I also discovered that I truly enjoy talking about science and presenting my work to people. So following up on that, I participated in another science competition that was a really, really enriching experience. This one was a team competition. It's called IYPT, or International Young Physicists Tournament. And this is really, really a nice format. There are many different types of science competitions, like Olympiads or so, that are more like exam-based, where you answer some questions on paper. This was much more hands-on. We had to solve little research questions, little problems with both an experiment. So we had to actually have some experimental results made in our school's lab and have a theory to explain them. So, and it had to be a small original contribution in some ways, because there was no black or white answer that we could find online or find in papers to that exact question. So we had to actually think on our own and extend work that had been done before. So really kind of like a research experience, and then present our findings just like you would in a real science conference. So the contest itself was us going up on stage, giving a talk about our findings, and then the opposite teams, the other countries' teams, trying to come and find weaknesses and ask us questions, and we had to defend our reasoning. And that's really what happens at a real academic conference. So this was an amazing opportunity as well. And I've stayed involved in this contest. So of course it was limited to high school students. Once I started university, I wasn't allowed to be a team member anymore, but I stayed involved as a juror, as a team leader, as a coach for the Swiss team. And I've been involved pretty much every year since then. And then at university, so I started studying physics. At the university I was at in Switzerland, there was no specific astrophysics specialization, so it was general physics at first in bachelor's. The first 2 years, you have mostly obligatory courses in a lot of math, a lot of just general physics. And in the third year, I started being able to specialize a bit more. I actually went on exchange. So my third year, I did it all the way in Canada, in Vancouver, an amazing city, amazing campus, really great experience. And I did my first university level research project there. I was looking into the nature of dark energy. So this mysterious force that is pushing everything apart and making our universe expand faster and faster. I was working on a telescope that's going to try to map the universe, or as much of the universe as we can, to track the expansion rate and try to figure out a bit more about what dark energy is. I then came back to Switzerland for my master's degree in the same university as I did my bachelor. And here I was researching gravitational waves. So I was researching what happens when two very heavy black holes collide. It's a very, very violent event. And the black holes will deform space and time. And we can actually detect those waves, those small deformations that arrive on Earth. And I was trying to analyze, if we measure those gravitational waves from those faraway black hole collisions, can we find out whether Einstein's theories, relativity, are true, or whether there might be more, there might be extensions to those theories. So that was my work, and this brought me all the way now to Cambridge. I applied for PhDs, was not sure I had any chance of getting it, but I tried. And I was right to try because I ended up winning a scholarship and being able to come here to Cambridge for my PhD. And I am now studying one of the biggest questions possibly in astronomy, which is how was the universe born? Where does everything come from? And to do that, so this is kind of a diagram of how we think the universe evolved. This is the Big Bang. We don't quite understand it yet. And then we know it's been expanding, and in the late times, it's expanding faster and faster. And you see here this limit. This is as far as we can see directly. So there is a limit to how far back we can look and to how far back we can detect light with telescopes. So we are looking at this oldest possible detectable light in the universe and mapping it. So this is a new instrument, new set of telescopes built in Chile in the Atacama Desert that is going to scan the sky for 5 years and try to detect this light from the edge of the observable universe, map it. And you see here, it's a map made on the full sky. We see tiny little fluctuations, hotter, colder, brighter, less bright. And those fluctuations are of the order of a few hundred millionths of a degree. So we are looking at the universe the way it was over 13 billion years ago, and we are mapping it to a precision of a few hundred millionths of a degree. And from this, we can analyze how do we think those patterns appeared, what created them, and we can backtrack further and try to understand what happened beyond this limit of what is visible. And we can turn back time all the way to the very first fraction of a second after the Big Bang to understand more about how the universe was born. So that's my journey, and happy to answer questions later.
Wow, thank you, Emily. So we're now going to go into the panel discussion and then follow that up with a question and answer. And I think I'm going to be reliant on Joe and Vanessa here because there's so much to discuss and so little time to do it. So we hope this is going to whet your appetite and get you more interested in asking questions about space. So my first question, if we haven't already excited our audience, we've spoken about things like dark energy, the birth and growth of the universe, geology, mining, satellites, telescopes, mobile phones. Why should our audience be excited by space? What are the things that are happening in space with technology, etc., that really might get them interested? I'm going to go to Kathy first for a response to that question.
Oh, great question, Stuart. And I think for me, one of the most exciting things, and I would say this because I'm into Earth observation, is that putting instruments into space in satellites gives us huge economies and efficiencies of scale that we could not achieve with similar sensors on the ground. So we're using a lot of information that's beyond the range of the human eye that gives us information. For example, with my old world, looking at rocks, what can we see? What are they showing that we wouldn't be able to see without those sensors? It gives us information about crops and the growth of those crops. Are they well? Are they not? Do they need targeted interventions like fertilizers? It enables us to monitor the environment in ways that we could not do without the use of satellites from space. And indeed, more than 50%, I think, of the essential climate variables that we're trying to monitor with respect to climate change are only sensed from space. So there's a huge perspective on that. Being able to use position navigation and timing satellites means that we can target our transport more efficiently, we can do more in that sense. And of course, without communications satellites, we would be reliant on a wholly different series of platforms. So I think there's just so much to be excited about at the moment. And that's before we even begin to look at the things that Jake is doing with respect to in-orbit servicing and manufacturing and just taking things off planet and making them more efficient.
Brilliant, thanks, Kathy. So you can be in agri-space, you can be in climate space, you can be in logistics, communications space, you can be in manufacturing. That it really is broad that as far as careers go. Nuala, from the university perspective, what are you talking to your students and your stakeholders about in terms of the exciting things that are happening in space?
I think one of the things that I'm very excited about and talking to people about at the moment is the Mars sample return mission. So that's hopefully going to be launching in 2026, but who knows? But if you haven't heard about it, they're planning to actually create a spacecraft that's going to be able to land on the surface of Mars, collect samples, and then bring these back to the Earth so we can actually study them on the Earth. Because although we have sort of studied Mars a bit actually on the planet using the rovers that are there, the sort of technology that we can do and how we can study them is nowhere near as what we can find out about these samples on Earth. So we'll be able to learn a lot more about Mars and sort of go deeper into that question of was there ever any life on Mars. So that's something that I'm like really, really excited about. And yeah, a lot of our students are as well.
Absolutely, life on Mars, brilliant stuff. Jake, you've covered some of the sort of stuff that you're doing in terms of space. You know, what are the key exciting things that you would like to highlight?
I think there's one really big thing I'm excited about. We're going back to the moon. I mean, that's incredibly exciting. It's led by America, but there's lots of other countries trying to do the same thing. And we expect to see the first woman landing on the moon in the next 5 years, the first person of color, and then a number of different people going to the moon after that, setting up a moon base. I mean, that's fantastic, right? But if you think about what they need to get there and stay there, that's where we need to start making more stuff in space. So either getting asteroids and getting water from there, or turning the ice that's on the moon and the south poles of the moon into water for them to drink or oxygen for them to breathe. And also then the logistics of getting people to and from the moon. So you're going to need a base. It's called a gateway in between the Earth and the moon for people to use like a staging post or a service station for them on their way to get to the moon. That's going to need fuel, it's going to need people, it's going to need food, it's going to need water, it's going to need ways of making things. And you get people talking about now making these really big like solar panel stations in space. So they'll be in space, they'll always get the solar energy from the sun, and they beam energy back down to Earth. So you don't need coal factories or power stations. You don't need to have massive solar farms on the Earth because you've got it up in space. And that can both help people who are in space already, there's people going to the moon, but also help us back down on Earth. So I think humanity going back to the moon, and then maybe Mars after that, if you believe a guy called Elon Musk, but that's a slightly longer term bet, I think. That's the really exciting thing for me.
Amazing stuff. So we can add energy and space energy into the mix of converging sectors as well, which is absolutely astonishing and fantastic stuff. Emily, from your perspective, what do you think are the most exciting things happening at the moment?
So there are a lot of exciting things happening in research. So for me as a cosmologist, looking at the evolution, the history of the universe as a whole, what always blows my mind is how much potential there is still for discovery, because we can now look back with telescopes such as the James Webb to galaxies that are over 13 billion years old. We can look so
You've
My
muted.
microphone was muted. I didn't do it. I don't know who did it. Anyway, so we can look so far and we can understand so much of the universe, and yet this is only about 4% of everything that's out there. There are mysteries, dark matter, the invisible mass in our universe. We know it's there, we see its gravitational effect, we have no clue what it is. Dark energy that's causing the acceleration of the expansion of the universe, all other galaxies, almost all of them, moving away from us faster and faster, we don't know why. And of course, this big mystery of the birth of the universe. So there is so much that we don't understand. And each time we make a breakthrough, each time we understand something new, it opens new questions. So it is really fascinating that it's a field that is constantly evolving, and you will never get bored. You will always learn something new, and there's always so much potential for research. And now with technological advances, with new instruments being sent both in space on satellites and also being built on the ground, we have now an era that we call precision cosmology, where finally the study of the universe as a whole is not just some qualitative science, but we actually get incredible precision in our measurements. And every year we get loads of data that add up And combining all this data together, we can really constrain our fundamental theories, our understanding of the universe. We can go and challenge Einstein's theories, quantum mechanics, try to put them together and really build a deeper understanding of the universe based on measurements. And those measurements will only increase in detail, in precision, in quantity in the next decade or so. So this to me is very exciting, waiting for these new data sets, as well as hoping for the next theoretical breakthroughs, hoping to be part of it, hopefully. Yeah, so much potential in this field.
Great stuff. Thank you very much. And I think that sort of data expertise and skills really cuts across everything, doesn't it, in terms of what we're trying to do in terms of our understanding and using that data for advancement of humanity and meeting global challenges, etc. So that kind of brings us onto the next question. Really, we've had a really exciting, interesting look into your backgrounds, into some of the things that you're working on, into where the exciting things are happening in space. An audience might be sitting there thinking, wow, this is a huge opportunity, but what sort of skills might I need to develop as an individual to tap into these future opportunities and get into this exciting sector? I'm going to start with Jake on this one. I think Jake, what skills are important to you in your role and for your business?
I need people that are good with money. So we're a startup company, right? So that means we don't have much money, but we have to try and make new products and sell it to people as well and keep it going. So that's a good skill that you'll get in anything, like learning how to manage your cash. Then I need certain different disciplines. I need engineers. So there's lots of different types of engineers. I need mechanical engineers, people that can actually physically build stuff and make stuff out of metal, for example. I need systems engineers, people that understand the different interactions between parts of a satellite or a spacecraft so that they can actually work together. And that can be a bit more theoretical than actually applied. I need electrical engineers, people that can work circuit boards and understand how the flow of electricity and the computation, the computers within a satellite work as well. And then I need a slightly odd type of fluidics engineer. So those are people that understands how gases and liquids interact and work and flow around a fuel tank or through a pipe. Because up in orbit, you haven't got much gravity. So liquid and gas in particular doesn't behave how it does down here. And if you ever think about that, where a lot of the time when you fuel up your car, you see a car being fueled, which is, by the way, what we're trying to do in space. We're going to have the nozzle that fuels your car. That's our nozzle in space. Gravity is what brings all that fuel down. There's a little pump in the nozzle, and then it just goes into your fuel tank because gravity keeps it in there. In space, it doesn't work like that because the fuel can just fly around everywhere, and the gas in particular expands in a very odd way. So we need people that understand how those things work. And that means I need people that know a bit about science and maths, as well as those people that know a bit more about technology and the making stuff. So resistant materials or other such things as well. And then finally, because I'm doing something that hasn't been done before across the world, I need people that make stuff, those engineers. I need people that can go and talk to it about people and sell it. So I need people who are good at humanities. I need people that are good at psychology or marketing or something like that, or maybe someone that can build a website. Those are really important skills to have before I then try and get people involved that are really good at diplomacy or law or other such things. You can go out and then make that happen to change the systems of the world to allow us to refuel spacecraft and make space more sustainable.
So a real wealth of opportunity there and skills needed across the board. Really interesting stuff. Kathy, from your perspective, and you mentioned things like EO earlier, and from the applications of satellite technology, what sort of skills are important for your role?
I think where do you start? Jake's done a good job of highlighting a lot of the fundamentals that we're also looking for, but we're also looking for people who have knowledge in particular sectors where data from space can make a difference. So that might be, as I said earlier, agricultural specialists, people agronomists who know how plants grow, what's the best way of supporting them, geologists, I've done that bit, but oceanographers and marine scientists, how can they harness what we're doing as well? And I think one of the threads that I see going through just about everything these days is the ability to understand coding and to be able to deliver some of it. You know, there is no question that artificial intelligence is going to be able to do some of that for us, but we fundamentally, as scientists and users of that data, need to understand what it is doing to the data so that we can put our fingers on the button and say, actually, hang on a minute, 2 and 2 doesn't make 5. And I think that's a really important piece that every one of us needs to embed into our daily lives today.
Great stuff. Again, coming back to that data point, again, it's being able to use data and work with data and analyze it is a real opportunity, I think. Nuala, from the university perspective, what do you talk about in terms of skills and importance in this particular sector?
Yeah, so I mean, I can talk about my role specifically as a science communicator. I mean, the skill is in the name. So communication is a really, really important part of my job. So being able to understand sort of like complex science and be able to talk to people about this with a range of ages is a really, really important skill for my job. And also another important skill is creativity as well. So I have to really try and be creative with making like fun activities for people so they can sort of understand space and science in an engaging way that will connect to them and their daily lives. So yeah, I really have to be communicative and creative in my job. If I was talking to someone wanting to go into like physics and astrophysics, I think you've really got to be a good problem solver. That's a very important skill in the space industry and also in astrophysics as well. So being able to figure out sort of being creative, though, is the best way to be a problem solver as well. Also finding creative solutions to problems and working things out in lots of different ways, and also having that sort of math skill as well is very important for going into physics and astrophysics and some of the jobs in the space industry, but not all of them as well.
Thanks. I'd imagine you're putting on a lot of events on and things, so organizational skills and
definitely
collaborative working and all of that kind of thing can be quite stressful. There's a lot involved in it, isn't there?
Yeah, I'm basically a space events manager as well. So yeah.
Fabulous. So Emily, from the more sort of technical side of things, what skills are important in your role?
So in my role, I would say, first and foremost, the spirit of a researcher is really based on curiosity. If you want to go into academic research, having that open mind, having that always wanting to know more, to answer questions, to push limits of knowledge, that is really important, and that's what forms the basis for a good researcher. Then in more technical skills, I'll second what some of the other panelists already said. Mathematics, abstract thinking is really important to study physics, fundamental physics, astrophysics, to make a research career out of those topics. You do need quite a lot of experience dealing with math and with abstract concepts, especially for the theoretical aspects of it. For the more observational and data analysis side, computer programming, definitely. So we learn coding already in undergrad at university, and we use it every day. Like, actually, my daily life as an astrophysicist is not looking through telescopes, not at all. I never do. I've never even seen the telescope that I work with. It's all the way in Chile. And one of them is in orbit, is in space, not even orbiting the Earth, actually, much further away. So actually, I get all of this data, and it's not pretty pictures and images. It's like series, very long sets of numbers, and I need to make sense of it. So all of this is computer programming. It's very important. And then research is inherently collaborative. There aren't really any more of those lone geniuses just making their own theory in their own time. It's all teamwork. So being able to work with others, to communicate your results, to present your results and get feedback from people and work in a team is very important, especially in an international team, because when such budgets and such experiments are at play. For example, this telescope that's being built in Chile, it's handled by a really big international collaboration with people in the US, in Canada, in the UK, in France, Sweden, Italy, Japan. and you need to be able to talk to all of them and to get to know them. And then the last one, I would say determination and being passionate about your topic, because research is quite uncertain. Not everything that you try will work. You'll have sometimes you do a really long calculation and it's wrong. You'll have a lot of code, a lot of errors in your code, a lot of plots that you make that look like nothing, that don't look anything like you expected. Sometimes it's just that you made a typo and forgot a bracket somewhere. Sometimes it's actually that you've discovered new physics. So it can be a bit frustrating at times. And if you are determined to keep going and to pursue your interest, and if you're really truly interested, that's what will help you push through those obstacles.
Brilliant, thank you. And I think that determination thing actually is something again that cuts across all jobs in all sectors, isn't it? I think it's really important to have that. You find in the work environment, not everything is going to go 100% your way, and actually there is a great deal of learning to be taken from things that fail, so that you can learn from them and do things in new ways, and it helps us to progress the world really, really quickly, which is great. The next question is about on sort of future career activities. So we've spoken about some of the great things that are happening at the moment in space, but this is more about where we're seeing the future opportunities in careers going. We know that technology advances. We know it's had a significant impact on all of the things that we've talking about so far. But where do you see the future career opportunities going into the future? So if we start with Nuala on this one.
Yeah, I mean, hard to predict the future, but something I'm really hopeful for that could be quite exciting is like space tourism. I mean, this might be a little way into the future, but yeah, that could be somewhere where a new sort of jobs and sectors are created where people actually being able to go into space and get to explore it as well. Jake sort of mentioned this about lawyers as well. Space law, as more and more technology and developed is going into space, there's going to be a lot more need for people with a good understanding of like space law, of international law, and also policy makers as well, to make sure that we are going into safe space and respecting it as well. There's a lot of issues with like traffic management in space, and also we've got a lot of debris going around the Earth with like different satellites as well, and this is a big problem. So having people that can understand it and create policies that ensure that we're protecting the space around the Earth and also into the distance as well is very important. And another big part, I mean, we've spoken about coding and technology. The development of AI at the moment is going quicker, I think, than a lot of us may even be able to understand, and this will play a massive part in the future of space, of AI integrating into it. There's people in my department who are using satellite technology and AI to like study farming fields and help farmers understand their crops, how they're growing and how they can improve it as well. So there's applications of AI. It's just endless possibilities of it. So it's a very exciting future of space. It's a massively growing industry, especially in the UK as well. I mean, it's crazy how it's gone from very few jobs now to just needing many, many people. So yeah, if you really want to get into space, there will be so many jobs for you in the future in a variety of different industries as well. Oh, Stuart, you're muted.
It's my turn. It's just to throw some statistics behind that. We're looking at a sort of currently a £17.5 billion sector to the UK economy, but a global one of $630 million that's expected to rise, I think, according to McKinsey, to $1.3 trillion by 2035. So significant growth figures in there. I'm going to throw it open to the rest of the panel. Has anyone got anything that they want to add to Nuala's response there in terms of future developments? Yeah, Kathy.
I think one of the things that I'm really seeing is the growth of interest in orbit activities, whether that's servicing and manufacturing. So what are the key skills? What's the difference going to be for a space engineer who is designing a satellite down here for launch, and then it's going to work up there, to how one works up there to manufacturing those space solar farms that Jake was talking about, or indeed how do you plug in your refueling mechanism? Those are all really new things that we're only beginning to scratch the surface of. What is the difference between what we've got now and what we're going to be doing in the future? And the reality is that future is only 3 to 5 years away. So what we're not teaching everybody enough yet, even in university at the higher levels, to really satisfy that. And I think the other thing is about us being able to pre-analyze some of the data that's being collected up there, because it's huge, huge quantities. We need to be able to pre-sort some of that data before we take it down here and work on it in data centers down here, because data centers are huge absorbers of energy, users of energy, and we need to make sure that we're doing that as efficiently as possible. Back to efficiencies, I think, is the bottom line for me.
Great, thanks, Kathy. Yeah, that efficiency and sustainability, big question again, cuts through all of this, doesn't it? Jake, did you want to pick up on it, anything around this question from your perspective?
Just very briefly, I mean, Nuala talked about artificial intelligence already, so understanding how we can utilize AI, and then the robotics angle. So everything we do in space and satellites, there's not normally a human there, there's not normally an astronaut, so we have to control it from the ground, and there's a latency effect that you can't do it in real time. So you have to basically program a robot, and it has to do what you want it to do, right? And so you need those coding skills and also understanding the physical robotics, how it moves and how it can be controlled. That's really important for space. It's important now. It's going to be even more important in a few years' time.
So thank you very much. So I'm going to jump onto the next question, and it's about
Stuart,
sort of advice and pathways. Yeah, I'm going to pick up the question in the chat as a part of this, if that's okay.
Lovely, thank you.
No problem at all. So we're looking at, and our audience today, and young people who are tuning in, have heard a lot about a really exciting sector, but they're thinking, well, what do we need to do to get into this sector? So my question is going to be around, what advice would you give young people with an interest in a career related to the space industry? But if we can start with Emily in response to that, but there's also a question kind of connected, that is, how much is your individual work connected to particle physics? Does your research into the origin of the universe relate to the work at CERN, or is it research independent? So if you can sort of respond that, and then go into the advice and how you got to be where you be, that would be really useful.
So
thank you.
Starting with the question in the chat, that's really spot on. Actually, my research is very related to particle physics. So it's actually quite surprising for some people that the study of the largest scales in the universe, really looking at the entirety of the universe that is so large, is tightly connected to the smallest particles. But the reason is that the contents, the types of particles that we have in our universe, dictate its evolution and its history. So depending on what type of particles we have at a certain stage, at a certain energy level in the history of our universe, it changes the expansion, the evolution that we observe. So actually, my work is related to what they do at CERN, because what they do at CERN is to collide beams of particles that are at very high energy, very high speed, to create new particles that only exist at those high energies, so that we wouldn't naturally observe anymore on Earth. And in a way, the very early universe is like a natural particle accelerator, because in the early universe, everything was smaller, hotter, denser, and the general energy level was much higher. So at those energies, maybe we see new types of particles, and the fundamental forces of nature unite, and the physics, the laws of physics are different than what we have now on Earth. So studying cosmic inflation, the fraction of a second right after the Big Bang, actually goes to energies that are about 12 orders of magnitude, so multiplied by 10, 12 times, higher than whatever we can achieve at CERN. And there is so much potential if we can understand the physics of this time right after the Big Bang to discover new interactions, new particles, and new forces of nature. So very, very tight connection between the two. And many of my lectures, the courses I had to take in my master's, were actually quantum physics, quantum field theory, advanced quantum field theory. I did a lot of that, even more than astronomy courses. And going on to the second question, what advice would I give young people interested in the space sector? I mean, my main advice is really go for it. If you're interested in something, follow your passion, and start looking for opportunities as early as possible. So as I summarized in the slide about my path, my journey, I started doing small research projects as soon as I could, reading a lot on my own, informing myself, interacting with people, maybe getting, if you get to meet someone who works in the space sector, to act as a bit of a mentor, to give you advice, to inspire you when things get a bit tougher. And of course, getting interested and getting involved in math and coding as soon as possible. So when you have the chance to pick options that give you a stronger background in those areas, that is always a good thing to do. And even if you don't end up working in the space industry afterwards, it will open many doors. I know a lot of my colleagues now at the PhD stage even find out that maybe research is not for them after all, that some aspects of it are not really what they like, but they can then move on to many different sectors, to data science, to the private sector. So there are many job opportunities if you go into this pathway, but end up finding out that this is actually not really for you, that you can bifurcate into as well.
Great, thanks, Emily. So, Kathy, from Satellite Applications Catapult, and you, the skills manager there, what advice would you give to young people interested in a career in the sector?
I think I'll pick up on something that Emily just said. Keep your options open. The reality is that studying science and maths won't stop you from doing anything if you change your mind in the future, but not doing them can limit your choices wherever you want to go. So keep it open, keep exploring, keep that interest, that excitement about learning more, and it doesn't matter where you go, you'll be able to have a fantastic career. But come to space.
Thanks, Kathy. We need to give you a flag to wave when you say that. Nuala, what about from the science comms, space comms side of things and the outreach side of things? What advice would you give people interested in sort of pursuing that career and more broadly in the space sector?
Yeah, I mean, if you've got a passion for science and space and you like talking to people about it and you enjoy that, then you'd be very, very good in a science communication job. It's really, it's a very fun job. I get to meet a lot of people. I get to travel around a lot. So, I'm sure some of you out there will be those people who just want to chat about space all the time. And if you're like that, like me, then yeah, you'd be great in a industry like this. And then sort of going into the space sector, and some of it is quite technical. You have to, study maths a lot of the time. You have to study science, and you can get things wrong in those subjects. But I think to know that it's really important to get things wrong in science and maths, and I got things wrong all of the time, and I'm sure all of the people here got a lot of things wrong when they were studying maths and science, and to not let that sort of put you off, and to really have faith in your own ability. If you enjoy science and you like maths, then just keep going with it. We will get things wrong constantly, but yeah, that's a really important part of it. So just keep going, and you'll get to where you want to go. And I also wanted to share, I hope that this link will share in the chat, but there's a really amazing resource that was created by Imperial, and it's funded by the UK Space Agency, that's all about space careers, and you can find loads of different jobs in there. You can find a career. It's got great resources for teachers and students that sort of shows all the diversity of different roles there are in space. I'll share that in the chat, and hopefully people can open that as well.
Great, thanks, Nuala. And so Joe will follow up with some good resource links as well. Jake, you mentioned so many different job opportunities within your company alone. What sort of advice would you give young people with an interest in the career in terms of pathways and their own personal development?
Thanks, Stuart. And yeah, I'll just be brief. I've got to drop off. I know we're almost at time. There's probably two things. Number one, it's just do whatever you think is cool and what you're passionate about. I never had like a 10 or 20-year plan for my career. It might be you do, which is fantastic, right? But actually just do things which you think are cool and interest you. Have a mission about what you're doing. So the thing that you're doing motivates you. For me, it's about stopping space debris. That's what I find really important, because I've got kids and I want them to be able to use space and go to space in future. And the second point is to be brave. Be brave in conversations like this. So ask your question, put your hand up, put something in the chat if you can. When you're at events or conferences, go up and start that conversation. Don't be afraid to go and just say, hi, can we talk about space or whatever. The best jobs I've ever had, including this one, came about when I had a conversation with someone and we were talking about something else, with a nice chat, and they said, oh, there's a job coming up you might be good for. That wasn't like advertised on a website and like that. It was just a one-on-one chat. And because I was a little bit brave and went out there and had that conversation, that's what got me that job. So to anyone who's thinking about having that job in future, please do be brave and make that step if you're ever thinking about doing it. Thank you.
Thank you. So before I hand back to Joe, we had one final question on kind of what it's like to work in the space industry. But I think that you gather from the whole conversation we've had that everyone thinks it's a fantastic sector to be in, and a really exciting and lots of opportunity. So just one last comment from each on you, just to give a quick overview of what it's like. Let's start with Kathy.
Just go for it, because no day will be the same as yesterday. And what's not to like about being involved in a sector that everybody says is so cool? And sometimes it is rocket science.
Brilliant. Jake?
Today I'm talking to you. Yesterday I was talking to someone from America, from Colorado. The day before that I was talking to someone from Holland and somewhere else. It's very international, so don't be afraid to go out and make your links wide. Learning a language is also quite good. It used to be Russian, not so important anymore. Chinese, French is really important languages, and don't be afraid to go out there and just have those conversations with anyone you want to try and make it happen for you.
Thank you, Jake. Nuala?
Yeah, I mean, as everyone says, it's a really great industry. But even if you don't want a career in this, just sort of staying interested in space, sort of learning about all these new discoveries. I mean, I still find all this stuff really, really fascinating. And you learn something new as joining.
Thank you. And finally, Emily.
Yeah, so I would say, what is it like to work in this sector? It's very exciting because you constantly learn something new. I'll second what other people said about no 2 days being the same. And that's really the case, because in my sector of research, you are pushing the boundaries of knowledge and doing things that haven't been done before, thinking about problems that have never been solved before. So there really is an excitement about that. And I will also second what Jake said about it being very international. As I mentioned before, I'm working in a really large collaboration that spans 3 continents. And that is a fascinating experience as well, with the kind of people that you meet from very different backgrounds. So that is very, very valuable to me as well. And I get to travel quite a lot for conferences. For example, this summer, in just a week's time, I'll be going to Chicago. Afterwards, I'll be going to Toronto and then to Copenhagen. And this year I've already been to Italy, last year to Munich and Paris. So I get to travel a lot, meet a lot of people from very fascinating backgrounds. Of course, sometimes the going gets tough. Doing a PhD is not always easy. It's competitive. There's some pressure. There is some obstacles on the way, some projects, ideas that don't work out. But if you have the passion for the topic, I think you can get a very, very valuable experience out of it, and make a great career out of being in the space sector.
Perfect. Thanks, Emily. I'd like to thank all my panelists very much for your insights and exciting comments this morning. I'm going to pass back to Joe.
So just for me to say huge thank you. That was so interesting, and I think probably has raised a lot more questions with the students. I have put my email address in the chat, so if I don't already have your email address, do drop me a line so I can share the recording. We've also started putting together any questions that we got previously with answers, so I can share that with you, and any relevant links for you. So thank you so much to the panel, and thank you all for joining us, and enjoy the rest of your day.
Thanks all. Bye bye.